Hello, good morning, good afternoon, welcome to Couchbase On Air. Today we have two presenters taking part in this hangout. First of all, we've got Gerald Sangudi, who's a software architect for Nickel, and Matthew Ravel, the developer advocate in EMEA. So we're going to hand over and discuss today about what's new in 4.0 and including Nickel. Over to you, Matthew.
Thanks, Laura. Hey, Gerald, welcome to the hangout. Whereabouts in the world are you joining us from today?
Good morning, Matthew. Good morning, Laura. I'm joining from Mountain View, California, where Couchbase is headquartered, and really excited to be here with Mia.
Yeah, thanks. So I'm guessing it's pretty early in the morning for you right now. So thanks for getting up early for us. Okay, so this is part of a series of hangouts that we're doing on Couchbase 4.0, leading up to the release later this year. So just to give a quick recap of what's coming in 4.0, the main feature really is Nickel, a new query language for working with JSON data. And you can find out more about Couchbase 4.0 and the other features that are included by looking on couchbase.com. But today we're going to focus in particular on Nickel. So Gerald, why do we need a query language for JSON? Hey, I think we lost you there, Gerald. Are you still there? Okay, well, let's just try and get that fixed in a moment. So let's just while we're waiting for Gerald to come back on. Oh, are you there, Gerald?
Yes, I am.
Ah, great. Sorry. So the question was, yeah, why do we need query language for JSON?
Yes, we need a query language for JSON because JSON is really the new way of storing data for modern applications. It is flexible, it is rich, it allows you to sort of encapsulate your data, really store your data in its normal form. And so given that we're storing data as JSON, it only makes sense that when it's time to query the data, introspect the data, understand what's in our database, we would need to be able to query it. And so having a query language for JSON really removes this impedance where you're storing your data as JSON, but really being able to query it or to consume it because there was no query language for JSON up until now.
That's a compelling case. But Nickel's actually very much based on SQL. So why base Nickel on something that is designed for perhaps an older age rather than coming up with something brand new from scratch?
Yeah, so we really wanted to give our users the best of both worlds. So we started out with a blank slate, really saying, all right, we have JSON, which is this really rich, compelling way of storing data. And we have SQL, which, as you said, has been around for a while. It is this really proven technology based on a very solid mathematical foundation. And so we said, well, do we start with SQL? Do we create something brand new out of whole cloth? And really, in doing a full open-minded, fair assessment, SQL was just the obvious way to go. It's proven. It works very well for what it does. It's familiar to many developers out there. So really reduces the learning curve. We did need to make to enhance SQL to enrich it for JSON, and we did that, and we'll talk about some of that as we go along. But the point being that if you already know SQL, getting started with Nickel is very easy. So there's an easy transition curve. I like to think of it like, let's say, introducing electric cars, right? Even though there's a new technology under the hood, there was no reason to sort of redesign, the seats or the steering wheel or the rules of the road. So it's just a way to let developers quickly get started and take advantage of Nickel and their database.
Great, thanks. So you did touch on there the idea that SQL needed to change for JSON. And obviously, JSON is denormalized. It's schema-free, or at least schema-enforced. So it's very different from the relational world for which SQL was created. So can you give us a glimpse into some of those changes that were necessary to turn SQL into NQL?
Yes. So in fact, the relational world and the sort of JSON NoSQL world, they are different, but they're also similar in ways that might surprise you. And so if you take a JSON document of attributes, same as just a record or a row, and if you have a collection of those and they all have exactly the same attributes, that looks very much like a table. So there are two things, two to three things that are really different between NoSQL and SQL, and really sort of relational, really around.
We might have lost you there, Gerald. Sorry, can you hear us?
Yes.
Hey, sorry, we've got you back now. Sorry about that.
I can
not sure
hear you. Can you hear me?
Yes, we can again now.
Apologize for my internet connection here.
No problem, it happens. So
Yes.
you were mentioning, yeah, the similarities, in fact.
Yes, yes. So the similarities really are, if you have a collection of JSON data that is all flat and all uniform, that's essentially the same as it's equivalent to a table. Where JSON is different is really, where it's really different and powerful is when you inject flexibility into this. So your documents don't have to be uniform.
Okay, we seem to be having some difficulties with Gerald at the moment. So maybe Matthew could continue and maybe look at what the other activities that are involved with SQL, or sorry, NQL.
Sure, I think Gerald's trying to rejoin us, so just while he does that, yeah, I mean, what I might do is leave the NQL discussion for Gerald for when he comes back, and just mention a couple of the other things that are coming in Couchbase 4.0. So one of those is something that'll be interesting to people who have been using the views engine. So NQL is our new querying method, but that doesn't mean the views go away. And with views, you'll soon, with 4.0, you'll be able to do more of the multi-dimensional querying and kind of geospatial style querying. Oh look, I think Joel is back. Let me.
Great.
Hey, sorry, it looks like you're back now.
Oh, my apologies. Yes. So can you hear me?
Yes, we can.
All right, sorry, just to finish the thought. So JSON really just gives you flexibility. You can have documents that are not uniform. They can vary from document to document. You can have different versions of your data. And secondly, they don't have to be flat. So you can have really rich structure, encapsulated structure, parent and child subdocuments all encapsulated together, which is the natural way that data exists in the real world and the natural way that your application consumes data. And so the way that NQL extends SQL is really by taking into account this flexibility of JSON, right? So being very robust in terms of not requiring a schema, not requiring uniformity of data, and also being able to query nested data, reach deep into subdocuments, multiple attributes, all of that kind of, everything you can do with your JSON data, you can query it using NQL.
Interesting. So, it sounds like a really major project to effectively create a new superset of SQL, new language basically, and then all of the underlying work. So, How did this project get started at Couchbase?
No, great. So we started on Nickel proper about 2 years ago, right? A little over 2 years ago. Before that, there was the intention to add querying at Couchbase. There was a project called Uncle. But Couchbase was busy building the underlying infrastructure in terms of the really high performance scale out Couchbase key value store, views, and so this was always understood to be a high priority. We just had to build out the underlying infrastructure first. So we built that out. Couchbase, as you all know, is highly scalable for all of the key value use cases. And so when the timing was right, we finally kicked off this project a little over 2 years ago. There was a lot of fun design work, lots of brainstorming, weeks on end in front of a whiteboard with lots of smart people, and finally we got down to brass tacks and started building. And so it's been a really fun ride along the way. And near the end, we actually found out that there were a couple of academics who were doing something similar, UC San Diego, UC Irvine, and so we actually got together and essentially began a formal collaboration. And so we really have this common vision of what is the proper, standardizable, really the correct query language for JSON.
So that sounds then like something which I've heard hints of before. The intention, the vision for Nickel is to be more than just Couchbase's query language.
Correct.
Okay, cool.
Correct. Yes. In fact, I just want to say one thing. So, in fact, we actually have, as I said, we're collaborating with these academics. We have invited others in the NoSQL space to take a look at Nickel and to sort of build their own implementations, to make suggestions. So it really is meant to be a very open and collaborative process. We're simply taking the lead, but we're leaving the door open for others to join as well.
Okay, great. So I think it'd be nice to have a look. You've mentioned some of what Nickel can do and some of how it differs. So it'd be great to see it in action. Is that going to be possible?
Yes, it will be possible.
Great.
So let me share my desktop here, and I'm going to switch over. Can you see my screen?
Yes, we can.
All right, excellent. So Nickel comes with what we call an online interactive tutorial. You get this both on our public site, query.couchbase.com, as well as if you install Couchbase 4.0, which is now in beta, Couchbase Server 4.0, you get your own local version of the tutorial where you can play around, you can make changes, and actually see Nickel in action. So this is a live interactive interface. I'm just going to highlight a query here, our hello world, and run it and show you how this works. Do you see what I've highlighted here, the query that I've highlighted?
Yes.
Excellent. So I'm going to click run, and voila, these are our results. Notice that the result is JSON. So we have, in this case, we simply have the greeting, our greeting hello world. Now, a few additional things that I'd like to highlight. So on the left, you have an index of all the features in the tutorial. Just to click on one here, let's click on where clause. So here we have a data set with people's names and ages. I'm going to click run, and the results here are a bit more interesting because there's more than one result. So we have an age, we have a name. You see that there are 4 result documents for ages 46 to 40. If I wanted to sort this, I can simply edit the tutorial window here, add an order by, let's say age, and let's do descending. So there you go. That's in descending order, age before beauty. So this just gives you a little flavor of what Nickel is about. I won't do too many examples. You definitely encourage everyone to try this out on your own. But in addition to the basics, we have a section on joins, which you see here at number 24. Click on the e-commerce case study, because this is sort of a full case study showing what an online store would look like, how you'd build that using Nickel. So this has a full set of example flavor. This first example is just counting all of the products in your inventory. If I click run, you get a result that shows that we have 900 products.
Cool.
Now click next to go to our next example. And on this next example, we're simply browsing products from page to page. And so this is showing product categories, and we're only going to look at 10 categories at a time. So if you are implementing a navigation page for your online store, you would want to show a few items at a time so that users could page from one page to the next. It's a bit more complex query, but so just to show you, do you see the results here?
Yeah.
Excellent. So each product has a category, in this case golf. There's a list of reviews, date modified, a description. I realize there's a lot of content here, but this is really what would be under the hood, your user experience for your online site. So that gives you a flavor of Nickel, and I think the tutorial is really the best way to get your hands on Nickel for the first time.
Great. So that's query.couchbase.com.
Yes.
Okay. All right. Thanks for that. That's great. So, other than the language itself, what's underneath Nickel? It's one thing to create the language, but how do you build the structure underneath something like Nickel with Couchbase?
Yeah, great question, Matthew. So really, our goal is to give you both a great language so that you, the developer, can be really productive, can express what you want, with a very simple syntax, and not have to write the application logic to manipulate your data, to query your data. The second part of that is to make sure that when you issue these queries, that you really get great performance, so that your applications run great, and so that your users have a great experience using your applications. The key to that is, underneath the covers, Nickel is making heavy use of Couchbase's, scale-out infrastructure, as well as heavy use of indexes, right? So Couchbase has had view indexes for a while. With Nickel, we're also introducing what are called global secondary indexes, which are really a powerful mechanism meant to, make your queries really fly with Nickel, right? So these will be available in Couchbase Server 4.0, currently in beta, and will release along with Nickel. And we have a lot of, resources around helping you, design your indexes, understand what indexes your query is using, so you can really get the most out of Nickel and Couchbase. In addition to being able to scale out your data, your Couchbase key value data store, you can also scale out your indexes, you can scale out your queries, scale out your query services, and when you put all these together, you get what we call multidimensional scaling. And so Couchbase not only scales in the dimension of data, we also scale in terms of your index capability, what part of your cluster is serving indexes, as well as query. So you really get 3 services all scaling out to give you multidimensional scaling and a very, very powerful infrastructure.
So you could choose some servers to be query servers, some to be index servers, and others to be what we've had all along, which are basically data servers.
Correct, exactly. And what we encourage people to do is when you start out developing and prototyping, you can simply install Couchbase Server 4.0 on your laptop, on your dev environment, and you simply, by default, all the services are enabled, so you get a single environment running all of your services, very easy, and you're all set to go. Once your application is built out, and you're ready to really start either testing it for performance or moving towards production, if you need to scale, people normally come to Couchbase for performance as one of the reasons. When you're ready to scale, then you can take that application and that Couchbase and simply by going through a checkbox process, just enabling services on one set of nodes, enabling other services on other set of nodes, you really get you're ready for scale.
Great, thanks. Now you mentioned that indexing is key to Nickel, and that we have these new GSIs, these new global secondary indexes. How are they different from views?
So, look, before I answer that, I just want to highlight one thing, which is that in Nickel there's an explain statement. And so for those of you who are familiar with SQL, you know that explain is really our secret weapon. That's what tells us what index is being used, why we're getting the performance that we're getting. Just wanted to mention that. In terms of global secondary indexes in comparison to views, first of all, underneath the covers, there's a different architecture. And so views live on your data nodes. And every time you query a view, it's going to touch all of your data nodes. A subset of the view is living on each node, and it's going to do something called a scatter gather. So it's going to say, okay, node 1 and node 2, I'm searching for this range of data. Give me the subset that you own, and then each node will perform that query locally. All of those will be combined together and finally returned to you. That is called a scatter gather. Global secondary indexes work differently. So the term global means that each index contains a global view of the entire cluster. And so the data for each single index lives on a single index node. Right? What this means is that you get much better performance. There's no scatter gather. It doesn't need to reach out across the network and collect this from several nodes. And so global secondary indexes really work much better for those use cases that Nickel is targeted for, right? Which is use cases where you're searching by a secondary attribute, right? So instead of your user ID in your session store, you're searching by email address, by last name, by location. The view indexes remain a very powerful part of Couchbase. They're great when you need to do your own custom JavaScript logic in your MapReduce. And also if you need a pre-computed aggregation. So the way the view indexes work is that with the MapReduce, they always contain the current aggregate value, and as you are performing writes in the background, that view is just incrementally updated, right? So the update is only incremental, and you always have your overall aggregate easily available to you without having to recompute the entire aggregate. So there's certainly a place for both. And again, we have resources to really help out our developers understand when to use each technology.
Great. This seems like a good time just to briefly mention that if you click on Q&A, if you've got any questions for Gerald about Nickel, then you can type in your question and we'll get to those throughout the rest of the Hangout. So yeah, click on Q&A, I think is in the left-hand side of the Hangout window, and then you'll be able to ask Gerald your questions. Okay, so the life cycle of a query in a relational database is fairly well understood. So, but you know, we're dealing with something somewhat different here. So, can you take us through what happens from the moment that I run my query to the point that I get the data back?
Yes. Yes, thanks, Matthew. This is actually the stuff that I love because I live in the guts of the query engine, and this, you know, I'm sort of nerdy that way. I get excited about this. When you issue a query and it comes back in a couple of milliseconds, in that span of you know, two milliseconds or so, a lot really happens. We parse your query, so we have a parser. You know, in a sense, a query engine is really a full stack little mini computer system, right? It's got a compiler, it's got a runtime, it's got an optimizer, it's got, you know, intelligence, it's got I/O. So you really get to touch all the different aspects of computing. In terms of the life cycle of a query, our query engine is stateless. It's you know, stateless server where you can just scale it out. Our clients, Couchbase clients, are what are called smart clients. They're cluster aware. When you issue a query, they simply know which nodes in your cluster have the query service enabled. They choose one of those nodes in a sort of load balancing fashion. The query arrives. It's got a statement as well as some other parameters. You know, how much parallelism to use. You know, timeout value, maybe some parameter values. We parse the query. If there's a parsing error, we tell you that. If it's completely fine, we then take that parsed syntax tree and we do what's called planning, right? We say, okay, given the available indexes, given what the query is requesting, what is the most efficient way to execute this query? This is called a planner or an optimizer. We go through that planning process, finally produce a query plan, and then hand that off to our execution engine, which finally executes the query. It builds an execution pipeline with, you know, worker processes. There are steps that do things like, you know, doing an index scan. Those will reach out to your index nodes and say, you know, here's my range, you know, min and max, lower bound, upper bound. We get those back. We then go do a fetch to your Couchbase key value store, saying, all right, I've done my index scan. Here are the actual document keys that I need in order to process this query. Those documents come back, giant calculator, you know, doing your aggregation, your expressions, the string concatenation, and then finally we do what's called a projection. So, given I want my results in this format, I want these particular fields out of my document, we you know, we do whatever sort you requested, and finally hand the results back to the client, you know, and depending on the query, all of this can happen within, you know, a millisecond or a small number of milliseconds. Obviously, for larger data sets and more complex queries, it might take longer, but it's really amazing how much we can do.
It really does sound like a lot is happening in that 1 or 2 milliseconds. So that brings me on to, although Nickel's quite new, do we yet have best practices for writing performant queries? Are there any tips that you've got?
Yes, yes, there are, and again, we do have many resources coming out with the Couchbase Server 4.0, including performance tuning. Give you a few here. There are two things I would suggest that you take note of. Two, what I would call your friends when writing Nickel queries. One is something we call use keys, which is one of those little enhancements, additions to SQL specific for Couchbase and for Nickel. And what that'll do is that will bypass, when you happen to know the primary keys of the you know, of the documents you want to query, this will bypass the index scan and go directly to the Couchbase key value store, fetch those documents, and then continue with the query processing. So tip number 1 is use keys when you can. Tip number 2 is something we call explain. Explain is really powerful. You just type explain and then your query, and that will tell you what would happen if you actually ran that query. All right, and at the very top of that result is your index. It'll show you either an index scan or primary scan, and what you want to look for there is to see an index scan, and that usually tells you that you're doing an index scan. It'll show you what ranges. And that's the best way to get a performant query is to effectively use your indexes. I'll mention a couple of things here. Again, in the spirit of performance, we have really powerful and rich indexes with Nickel. We have what are called composite indexes. So you index not just a single expression, but you can index several expressions. And what that lets you do is to get more selectivity. So if I have a query and I'm searching on email and last name, right? So I can have a single index that contains both email and last name, and what that will achieve is that my index will be more selective. So when the query comes in, instead of just finding all the people who have the last name of Smith, it'll find all the people with the last name of Smith and email in the yahoo.com or gmail.com domain. Which will the index, the better your query will perform.
Great, thanks. So, I mean, Nickel's new. We're seeing the first GA in 4.0 later this year. But what comes next for you guys on the Nickel team? Once 4.0 is out the door, I guess you're straight back at it, doing new things with Nickel. So what comes next?
Right. In fact, we're back. We're at it now, right? So, in secret, even though we're wrapping up 4.0, we've already started. We're sort of peeking through the window to the future, and have started some of those discussions and planning and design actually. So a few things that were able to make it into 4.0. Prepared statements. So what this means is that you plan your query once. And you can execute it many times with different parameters. This is very important when you have a long-running application. With ad hoc queries, you just sit at the terminal and just type what you want. But if you're actually building an application where the same queries will be executed many times over and over, you really want to use prepared statements where you plan the query once. The server, the query engine retains the execution plan. You have a prepared statement on the client side, and you just pass new parameters, and we just execute it as efficiently as possible. So that made it into 4.0. Functional indexes. You can not only index simple data attributes, you can actually index, completely arbitrary expressions. So you can, index on uppercase of name. That way you can, you'll find the data regardless of whether it's stored in, uppercase, lowercase, or mixed case. So lots of really advanced features already available in 4.0. In terms of the future, lots of exciting things. We're thinking about indexing on array elements, right? So individual elements inside of a JSON array. Things like being able to create materialized views declared using Nickel. Being able to use Nickel in a federated fashion, right, across multiple data stores. So lots of really powerful features. Security. Just think of the whole gamut. What I like to encourage people is to say, just think of all the databases that are out there. Open any one, look at the manual, or look at the feature list, and whatever feature you find is probably somewhere on our backlog. So we're really excited, looking to the future as well as the present.
Yeah, me too. I can't wait to see what people do with Nickel. So Gerald, thanks for giving us an insight into what's happening. Is there anything else you want to mention before we wrap up?
I would really just encourage everyone to try it out. I would say, in addition to bringing you Nickel, Couchbase Server 4.0 really makes the experience of getting started with Couchbase very, very easy, right? Like I said, we have these online tutorials. We're going to have a hosted Couchbase environment, real apps where you can get started without ever downloading anything. All you have to do is just point your browser, and you're off and running. The actual download and install is much, much simpler. It's all just GUI based, and so even though we have this really rich, powerful functionality, we've made it very easy and accessible for developers to get started. If you love SQL, I think you're probably going to love Nickel. If you love JSON, I think you're probably going to love Nickel. So we're really trying to give you the best of these two worlds combined.
Great, thanks. Yeah, like I say, I can't wait. So thank you, Gerald. Thanks also, Laura, for the introduction earlier on. And yeah, if you want to find more about Nickel, then give it a try, query.couchbase.com. Download the Couchbase 4.0, Couchbase Server 4.0 beta from couchbase.com. And yeah, give it a go, tell us how you get on. And you can always find us at forums.couchbase.com. Gerald often is answering questions there, as well as other members of the Nickel team and other people from Couchbase. So yeah, thanks a lot, Gerald. And thank you those who've joined us, whether it's right now live or on YouTube later on. So goodbye.
Thank you very much, Matthew. It was great fun.
Thanks.